And then we will now move on to the waste heat case studies. I would like to invite our first presentation from Sara.
Good morning. Good morning, everyone.
Good morning. Thank you for joining us. We're very pleased to have you here and very interested to hear about the cement plant case study in Slovakia.
Thanks to you, Hans. Can you see my screen?
Yes, we can.
Perfect. Good morning, everyone. I'm Sara Buonomo, sales engineer in TURBODEN for industrial heat recovery applications, and I'm here on behalf of the CRH group, who is unable to join us today, to introduce how the ORC technology can effectively harness residual low-grade heat in the cement production. Specifically, I will demonstrate how this technology is leveraged to enhance the process efficiency, sustainability, reduce the carbon footprint associated with the cement production, and in particular, we'll explore an ORC installation in a cement plant in Slovakia owned by the CRH company. For those who are not familiar with the topic, the organic ranking cycle systems have the capability to generate both electric and thermal power by harnessing various sources, including renewables, waste incinerators, engines, gas turbines, and even waste heat from industrial processes like cement production. Unlike the traditional steam turbines, the ORC systems employ an organic fluid instead of water. This eliminates the risk of turbine blade erosion, which can occur with steam turbines. In order to achieve the maximum efficiency in energy production in the ORC technology, TURBODEN, as global player, exemplifies a strong commitment to effectively harness waste heat with the maximum efficiency in energy production. Among the working fluid, the working fluid can be refrigerants, siloxanes, and various types of hydrocarbons instead of water. This choice represents a significant advantage in terms of water consumption, as ORC systems can be configured to operate without the need for water. This makes the ORC a compelling solution, particularly in countries facing the water scarcity issues that are projected to become more prevalent worldwide. Another notable benefit for many industrial plants is that the ORC technology excels at utilizing low temperature heat sources to generate electricity with high efficiency. In addition, there are several other key advantages for the ORC technology. The good efficiency, first one, the good efficiency at partial load. The ORC has a high flexibility and a wide operational range, since it can be easily worked between the 10% and 110% of the nominal load, with an average availability higher than the 98%. Another factor that, together with the efficiency, is crucial for maximizing the annual energy production of the ORC system is the automation. The ORC systems have a high degree of automation that allows the operators to focus on the core business operations. Moreover, no major overhauls are required in an ORC plant. So, why choose the ORC for energy efficiency? First and foremost, the ORC technology enables the generation of profit by harnessing currently wasted heat sources. Furthermore, the ORC systems allow the factory where they are installed to reduce specific production costs by decreasing the energy demand. This reduction in energy consumption contributes to improved sustainability within a sector like the energy-intensive industries, while also helping to mitigate the CO2 emissions and contributing to the decarbonization efforts. Moreover, TURBODEN ORC systems can be easily integrated into the existing industrial processes without impacting the normal operations. So let's move to the heat recovery in the cement industry. In cement production process, the ORC systems can produce electric power by recovering waste heat from two hot gas streams, the kiln preheater gas and the clinker cooler gas. The thermal power recovered in this way is efficiently converted into electrical power using the ORC turbine. The electric power produced can be utilized to meet the electricity demand of the cement plant itself, reducing the amount of the electric power that needs to be purchased from the grid. Typically, the generated power can account for 10 to 30% of the cement plant's total electric consumption, meaning that its monthly electric bill can be reduced by the same percentage. So the waste heat recovery is not a new topic in the cement industry. There are already more than 700 WHR plants in operation since 20 years in the world, and the potential of thermal power to be recovered is still very huge. Among the most interesting ORC plants in the cement factory, there is the CRH group for Danusem in Slovakia, started up at the beginning of 2014. That is one of the two projects the CRH group developed with TURBODEN, in which the heat contained in the preheater and the clinker cooler exhaust gas is transferred to the ORC systems that produces 5 megawatts of electric power. Let's see an illustrative movie of the plant. Oh, sorry, maybe I can show you the movie. Just a second. I'm sorry. I'm recovering the movie from the original source. Sorry. I'm going to share the screen again. Okay, maybe I can show you it later and go on with the presentation. Okay. So in the next slide, we have a graph with the operating data recorded for the CRH group plant in Slovakia. In the graph reported here, in white, the trend of the electric power produced for a time period of 1 month, resulting to be constant at about 4.5 megawatt electric. The plant resulted to have 57,000 operating hours since the startup in the 2014, and consequently more than 31,000 tons of CO2 avoided, thanks to the generation of 220 gigawatt electric power produced since the installation, with a percentage of cement plant electric consumption coverage of the 20%. So the ORC with its electric energy production is able to cover the electric consumption required for the cement plant for the 20%. In this final slide, I'd like to draw your attention to the scenario of the electricity prices in Europe in the past years, and it's skyrocketing throughout all Europe. In this context, waste heat recovery represents a crucial solution, able to decrease companies' reliance on conventional energy sources, leading the to the cost savings and to plant energy efficiency, contributing at the same time to a more sustainable and efficient future, thanks to the valorization of sources otherwise wasted in the atmosphere. Thank you for your attention.